Today it's practically a practice day, except that we see a little new notation right here. Okay, so people look at this. They may not know what it stands for. It's not IN. It's called LN. That stands for natural log. Now, I'm not sure if you find this a little bit strange because when we say natural log, shouldn't the N's be written before the L, natural log? Why is it LN? Well, if you look at the little description above, the reason why we call it LN is because of the origin in Latin. So, which I'm not going to try to say it in Latin, but there you go. You understand why it's LN, not NL. So natural log is simply saying log base E. Okay. Now I'll tell you this. I'll tell you this first. LN is something that you will use so much in the future. Okay. Not common log, not log of any other basis. What you will use a lot would be natural log in the future. Okay, especially when you go on to calculus, you see natural log all the time. Now, the way we treat natural log is exactly the same as any other log that we did yesterday. Okay, people like to write down to use natural log because well, it's a lot nicer. It's a lot simpler. There's no subscript to worry about. Okay, so if you look at number 1. For example, how do we combine number 1? Combine those two logs together. We have two logs, and they are subtracting each other. So we say, well, you combine them together, and that becomes what over what? Oh, actually, my bad. Sorry. There are two ways you can do this. You can do this first. You can say this is x squared in the numerator over x to the 4th, okay, which is equal to natural log of 1 over x squared. Okay, you can do it that way. Now, an alternative is that, and this is what I want you to see actually. Ready? The other way to see it is that, can you see natural log of x over here and natural log of x over here? So the way you can view this subtraction is that natural log of x is like your identifier of two like terms. They're like terms, basically. So instead of doing what I just did, what you can do is that, wait, hold on. I see 2 natural log of x minus 4 natural log of x. That becomes, well, what's 2 minus 4? We have 2 natural log of x. And then, well, you can either put this as an answer, or we actually would put the coefficient back to the exponent. So natural log of x to the negative 2 power, which is the same thing as natural log of 1 over x squared. So I want you to learn how to look at this as a couple like terms, and you combine them together. And so if you use this lens, look at number 2. Can you see 2 like terms that are adding together? Can you see we have a natural log of 5, and then we are adding with 2 natural log of 5. So how many natural log of 5s are there? 3. And by the way, one thing you can see here is that I dropped the use of parentheses. It's optional. Okay, you may use parentheses like what I showed over here, or you can just skip it. That's okay. It's not gonna cause any problem. So if you want to combine them into a single log expression, so this would be a natural log of 125. Okay. All right. Now, what about number 3? Now, number 3, can you see we have a natural log of x over here? Okay. Well, but there's a square root of x. So one thing we can do is to change the square root of x to x to the 1/2 power, right? And then we can move the 1/2 up front. So 4 times 1/2 becomes 2. So what's the result of this? That would simply be 0, because 2 natural log of x minus 2 natural log of x, that is a 0. Okay. So this is why this is actually what you will see a lot. Okay, we would like to make them into like terms. So take a look at number 4. So something that should spark your interest would be the appearance of natural log of 5, except that the third term is not exactly natural log of 5. So what can you do? -1, right? So 1/5 is equal to 5 to the -1 power. So I can actually rewrite this whole thing to this. So 5 to the -1 power, it's natural, well, 5 to the -1 power, it's 1/5. So the -1 gets sent to the front. So that makes the minus to a plus sign. So if you look at this all together, you have 4 natural log of 5. Okay. Yeah, I think you either look at you can either put it like this, or natural log of 625, which is 25 squared, or 5 to the 4th power. Either way. Okay. And then the next one, you can see that you can see the natural log of x being the like terms here, so we can combine them. This is natural log of 7. Can't do anything about it, so just going to leave it there for the moment. So after you combine the like terms with the natural log of x, you should have how many natural log of x remaining? You have positive 1/2 natural log of x minus 3 natural log of x. What's 1/2 minus 3 in fraction? -5/2. Okay, so that's what you have. Okay, and then you have to combine them into a single log. So natural log of what over what? So we'll say is natural log of square root of 7 over square root of x to the 5th power. Okay. If you leave it like this, I'm happy. Now you may go a little bit further and say, wait, hold on, I can see some kind of this is the power, remember? This is the exponent. Okay. You may say, wait, hold on, Mr. Chan, I can see some simplification. It's square root of x to the 5th power. Should I write like this? X squared being simplified, reduced from the square root of x to the 5th times square root of x. That would be wonderful if you do that. Okay. If you say, Mr. Chen, I can see the need of rationalization. Okay, you multiply by square root of x over square root of x. Then you have square root of 7x over x cubed. That works too. Okay. So I just want to make sure that you know how to put them all together. That's all I care. And for number 6, there is, well, there's nothing you can combine them together. They're all different. So all you will do is to put them into a single, well, in this case, that's a subtraction. So we have a fraction right here. Can you put them into a fraction? Okay, so in the numerator, Or just a little reminder from yesterday. Yesterday I shared a shortcut with you, if you remember. The shortcut was that if it's positive, it is in the numerator. If it's negative, that's in the denominator. So you can look at the minus, right, the negative term right here. That is clearly xy raised to the power. That's the denominator. That's easy. What about the numerator? Clearly, there's a need of square root because you have the 1/2. 7x plus 7 would be very nice. Okay, or 7 parentheses x plus 1. That would be very nice as well. So this would be it. Because these two are multiplied together. Okay, so that's how you get 7x plus 7. And the last one right here, number 7, is natural log. Okay, again, that's going to be a fraction because you see a subtraction. So what would this fraction be when we combine them together? In the numerator, there should be x to the 4th power. And then cube root of w over z to the what power? 14. Okay, so the 7 becomes the exponent of z squared. So the two exponents will multiply. So again, what you learned previously about the exponential exponent properties, they are very relevant. And they will continue to be very relevant.